Any other number system to decimal, then multiply. Multiply by which number? From which number to decimal you are converting, from that number you have to multiply. What is the equivalent value of this 0? For 0, 4 to 1 format you take. By adding, which number I can get 0? No need to add any number, so it will be 0. If it is binary to hexadecimal, then it is just easy. 8421. 8 plus 4, 12, 12 plus 2, 14, 14 plus 1 is 15. I have to go with grouping of 4 digits here. Hello everybody, a warm welcome to one and all. Welcome back to the session 7 of Unit 1 in BCA's first semester subject called Fundamentals of Computers. I'm Rohini TS, Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence, MYSURU. So before getting into our today's session, we'll just have a quick recap of our previous session. In the last session of this unit, we had a discussion regarding the conversion of number system, right? So in that, I had a discussion regarding binary to decimal, how we are going to convert the binary number system into decimal and also from decimal to octal, and we got to know regarding octal to decimal number system. So you need to remember one thing here, decimal to any other number system, divide. Any other number system to decimal, then multiply. That is the 2 points that you have to remember. So in our today's session, we're going to learn about these many topics. This include decimal to hexadecimal and vice versa, that is hexadecimal to decimal, then binary to octal, octal to binary, binary to hexadecimal, then hexadecimal to binary. So you need to understand what it is, from where to where we have to convert. Fine, we'll go with the first type, that is all regarding what? Conversion from decimal to hexadecimal. Here you can see that first I have a word called decimal. So I need to convert this into hexadecimal. Then we have to divide. We have to divide the decimal number by which number? To be converted data, that is what? Hexadecimal. So it should be divided by 16. If I am giving my decimal number as 512, that should be divided by 16. So what is the steps we have to follow? Divide the decimal number by 16. After that, we have to take the remainder and record it on the right side. So here we have to record. We have to look into the remainder and what is the quotient that we are getting. In the step 3, we have to repeat this step 1 and step 2 until the quotient becomes 0 or where we cannot further divide the decimal number. Up to that, we have to divide this. Then, after writing all these things, you will be able to understand the first remainder what you got while dividing, then that is considered as LSB or least significant bit. And the last remainder is what? MSB or most significant bit. And you have to write the solution from MSB to LSB. It will be in this way. So, from the last remainder to first remainder, you have to write. Okay, we'll see the first example now. So here I have a decimal number, that is what? 16,242, which is of base 10, should be converted into hexadecimal. You need to understand, when it is decimal number, it will be a combination between 0 and 9. But when it comes to the hexadecimal, it will be 0 to 9 and A to F. So the remainder can be more than 10. So if it is more than 10, we have to write a equivalent value of A to F. We'll start dividing here. First, what we have? 16,242. This is my number, that is decimal number, should be divided by 16. Let me write the table first. This is what 16th table. So by looking into this, you will be able to divide it. Fine. So here 16 tens, I am taking 3 letters here, 3 numbers I am taking, 162. So 16 tens are how much? 160. I am having a remainder 2. So it will become 24 now. So then I will divide it by 1. 16 ones are 16. So 24 minus 16 will be how much? 8. It become 82 now. So then 16 fives are how much? So here you can see that 16 fives are 80. So that 82 minus 80 will be the remainder of 2. So now my remainder is 2. What is the new quotient here? That is 1015. We have to start dividing it again by 16. So here you can see that 16 6 are how much? 96. So 101 minus 96, the remainder will going to be 5. So now it become 55. Then 16 3s are 48. So if it is 48, the remainder will be 7. So 55 minus 48, 55 minus 48 will be 7. That remainder will comes here. So here again we need to divide this 63 by 16. So 16 3s are, I cannot take 16 4s. Why? Because this become greater than the quotient. It will become 64. So now I have to go with this 48. What it mean? 16 3s are 48. So 63 minus 48 will be 15. The remainder is 15. This is what? My MSB or most significant bit. Okay. So now here we have 3. Can we divide 3 by 16? No. At the time what we can do? 16 zeros are 0 and the remainder will going to be 3. So now it become 3, 15, 7, 2. 3, 15, 7, 2. But we know that we don't have any number 15 in the hexadecimal. Though we have, it is considered as F. Why? Because the 15, value 15 is equivalent to F. So instead of this 15, I need to write 3F7 2, which is of base 16, because we are converting from decimal to hexadecimal. This is how we are going to divide or to convert any given decimal to hexadecimal. So if you are getting a reminder between 0 and 9, write as it is. But if you are getting more than 9, that means 10, 11, 12, 13, 14, 15, up to that if you are getting, then convert that into its equivalent hexadecimal number. Then you will be able to get the right answer here. Let me go with one more example here. Consider 518. This is of decimal number, should be converted into hexadecimal. Fine. Let me divide this by 16. Let me write the table. Okay, fine. So here 51. I will going to start with 2 character, that is 2 numbers, 51. 16, how many is a 51 I can get? I can go with 16 3s are. 16 3s are 48. So 51 minus 48, I am left out with 3. So now it become 38. Now I will go with 16 2s are. 16 2s are 32. The remainder is how much? 6. So I can directly divide this 32 by 16 by 2. 16 2s are 32. The remainder is 0. And here I cannot divide 2 by 16. So I will take 16 zeros is 0. The remainder will be 2. This is my MSB. The first, this is my LSB. I have to write the answer like 206, which is of base 16. 206, which is of base 16. Okay. So here I didn't get any number or any remainder which is greater than 10 or greater than 9. That's why we got only 206 as a solution or a converted value of this 518. I hope you all understood regarding this conversion from decimal to hexadecimal. Let me go with the vice versa. That is what? Hexadecimal to decimal. Any other number system to decimal? Then multiply. Multiply by which number? From which number to decimal you are converting? From that number you have to multiply. What is the step? Start at the rightmost bit and take that bit and multiply by 16 power n. So 16 power 0, 16 power 1. In that manner you have to write, where n is the current position beginning at the 0 and increasing 1 by each time. 16 power 0, 16 power 1. In that way you are going to write. Then we have to add all the products. After the addition, the resultant will be equal to the decimal value of the given hexadecimal number. Okay. We'll start with the first question. That is what? 5AF. This is what? Hexadecimal point, and D, which is of base 16. We have to convert this into its equivalent decimal number. How we are going to do that? Let me start with the first number. That is what? 5. 5 into 16 plus, what is the equivalent value of A here? That is 10. Equivalent value of F is 15 and equivalent value of D is 13. Directly I am taking that here. So plus 10 into 16 plus 15 into 16 plus 13 into 16. Here whatever the number which we have left side to the this hexadecimal point, we have to give a positive weightage, which is at the right side to this hexadecimal number. We have to give the negative weightage. For this D, that is 13 into 16, it will become -1. For here, 16 power 0, 16 power 1 and 16 power 2. 5 into 16 power 2. That means what? 16 into 16. It will become 256 plus 10 into 16 power 1 is 16 itself. Then 15 into 16 power 0. Any number with power 0 is always equal to 1. That's why 15 into 1 plus 13 into, how we are supposed to write the negative weightage here? If it is 16 in -1, then 1 by 16. If it is 13 into 16 power -2, then 1 by 256. 16 into 16 is 256. In that way you have to write. So 13 into 1 by 16 here. If I am multiplying, I will be getting 1280. 10 into 16 will be 160. 15 into 1 is 15. And here 13 into 1 by 16 is 0.8125. By adding all these three together and fractional part these together, then we are able to get 1455. Then hexadecimal point 8125, which is of base 10. This is equivalent to which number? Decimal number. Therefore, this 5AF hexadecimal point D of base 16 is equal to this decimal number here. I hope you all understood how we are going to convert from hexadecimal to decimal. So, till now we got to know how we are going to convert from decimal to any other number system or any other number system to decimal. Fine. So, now we are going to start with a conversion from any other number system to any other number system other than decimal. We'll see the first type of conversion here, that is from octal to binary. Octal to binary. So if I say octal, that consists of what? It will be consist of 0 to 7, and I am converting that into binary. That is what? 1 and zeros. So it will going to have only 1 and zeros. Its base is 8 and its base is 2. We have to convert from octal to binary. How we are going to do that? We'll see the step. Take the each digit from octal number. So whatever the number we have in the octal number, we have to take it and then convert each digit into 3-bit binary number. So what we have to do? I have to take each octal number and I should write its equivalent 3-digit binary number. Already I told you regarding 8421. Fine? 8421. If I wanted to write the equivalent of 7, by adding which and which number I can get 7? By adding 4, by adding 2, by adding 1. So 4 plus 2 6, 6 plus 1 is 7. So here for 8 I am going to give 0. This is what equivalent value of the 7. So here we have to take only 3-bit equivalent binary number. No need to take 8, only we have to take 4 to 1 format. If I wanted to write 3, then I have to add 2 and 1. So it will become 0 1 1. For 1 0 0 1. For 4 1 0 0. For 5 4 1 4 0 1. Okay. So in this manner we have to write. So after writing that each digit will going to be represented by a 3-bit binary number, as we done in the number system table. Here you can see the table. Here we had written the equivalent value of octal here. So I have an octal digit 0, 1, 2, 3, 4, 5, 6. What is the equivalent value of this 0? For 0, 4 to 1 format you take. By adding which number I can get 0? No need to add any number. So it will be 0. For 1, 0, 0, 1. For 2, it will be 0, 1, 0. For 3, it is of 0, 1, 1. And for 4, 1 0 0. For 5, 1 0 1. 6, 1 1 0. 7, 1 1 1. Okay. We'll see the first question, then you will be able to understand here. First, what is the question? 456, which is of base 8, needs to be converted into binary. So I know the equivalent value of 4. What is that? 1 0 0. And I know the equivalent value of 5. What is that? 1 0 1. For 6, it is 1 1 0. So all these are what? Equivalent value of each octal number. So from the first number to last number, I am going to write it together. Then I will put the base as 2. This is what? The conversion from octal to binary. So here 1 0 0, 1 0 1, 1 1 0, which is of base 2, will be equivalent to this octal number. We'll see one more question here. 123.36, which is of base 8, should be converted into binary. How I am going to write? For 1, what is the equivalent binary number? 0, 0, 1. Let me write 4 to 1 format here. 0, 0, 1. For 2, it is 0, 1, 0. For 3, it is 0, 1, 1. For 3, again it is of 0, 1, 1. For 6, it is of 1, 1, 0. Fine. How I am supposed to write? Here I have a octal point. So for first 3 numbers, I have to write as it is 0, 0, 1, 0, 1, 0, 0, 1, 1. I will put binary point here. After that 0, 1, 1, then 1, 1, 0, which is of base 2. Okay, this is how we are going to write the equivalent binary number. Fine. Let me go to the next concept, that is what? Binary to octal. So this is just what? Inverse. So if I have a octal to binary, then I will write the equivalent 3 digit. So if I have a binary, then I will what? Make a group of 3 digits here. So take a binary number in a group of 3 and use the appropriate octal digits in its place. Then begin at the rightmost 3 bits. If we are not able to make a group of 3, then we have to insert zeros to the left until we get the group of 3 bits each. After that, we have to write the equivalent of each group. Then we have to repeat until the conversion has been done. We'll see the first one here. Here I have a number, that is binary number 110111011, which is of base 2, should be converted into octal. We have to start a grouping from the right side. So let me take this first. Okay. After this one, and then this number. Okay. Fine. What is the equivalent value of 110? If I am writing 4 to 1 format, 11 is what? 4 plus 2, 6. So it is 6. Then 111 is 7 and 011. This is what? 3. So it is equivalent to its octal number. Okay. This is how we are going to write. And for this one, am I able to make a group of 3? I can take this as one group, and here we have only what? 2 digits. So I have to insert one more 0 here. Now it become group of 3. So here, what is the equivalent value? It is 2, and for this equivalent value is 5. So 25 of base 8 is the answer for this equivalent binary number. Okay, this is how we are going to convert from binary to octal. We'll see the next type of conversion, that is what? Conversion from binary to hexadecimal number. Binary to octal we done, that is group of 3, 4 to 1. So totally I can get up to 7. If it is binary to hexadecimal, then it is just easy. 8, 4, 2, 1. 8 plus 4, 12, 12 plus 2, 14, 14 plus 1 is 15. I have to go with grouping of 4 digits here. So that take a binary number and in a group of 4 and use the appropriate hexadecimal digits in its place and begin the rightmost of 4 bits. If you are not able to make a group of 4, then we have to insert zeros to the left. Whatever we have done for binary to octal, same thing we have to do here. We'll see the first question here. 10110001, which is of base 2, should be converted into its equivalent hexadecimal number. So from here I am going to make a group of 4. Here I have left out with only 3 digit. I will add 0 to it. Then how it will be? So 1011 will be one group, 0101 will be another group. What is the equivalent value? If I am writing 8421, 4 plus 1 is 5. Here 8421, 8 plus 1 is 9. So it will become 59, which is of base 16. Okay. In the same way, we are going to take some more digits and we will be converting it in its equivalent hexadecimal number. Let me see one more question here. 11001011010110. So first I will make a group of this one. After that, group of 4. Then this is a group of 4. So now I left out with only 2 digits. So I need to add 2 more zeros for this. So it will become 0011. So 8421. What is the equivalent value of 0011? That is what? 3. And this one 0001 is 1 and 8421 again. Then 4 plus 2, 6. then 1 0 1 0, 8 4 2 1, 8 plus 2, it becomes 10. What is the 10 in the hexadecimal? That is A. So we have to write A, which is of base 16. Okay, 316 A, which is of 16. This is how we are going to do the conversion. I hope you all understood regarding binary to hexadecimal. We'll see the next type, that is what? Hexadecimal to binary. Hexadecimal to binary. I am going to get some combination of 0 to 9 and A to F that should be converted into its equivalent binary number. Convert each digit of hexadecimal to 4 digit of binary number. We have to write the equivalent value of binary number. Then we have to combine all the resulting binary number into a group of a single binary number. We'll see the first question here. What is the question? CEBA. So already you know the value of CEBA. Already you know that. So C, that is equivalent to 12, and E, that is equivalent to 14, B is 11 and A is 10. Fine. What is the equivalent value of 12 in the binary? I am going to take 8421 format. By adding 8 and 4, I can get 12. So it will be 1100 for 14, 1110 for 11, it is 1011, for 10, it is 1010. Starting with the first number, second number, third number and fourth number, you have to write all these together, and at last you need to write that radix or a base as 2. Then this is what the equivalent value of a binary number for a given hexadecimal number. Okay, we'll see the next one more question here. Let me consider phase point 1 2, which is of base 16, should be converted into binary. Okay, what is F here? That is 15. If it is 15, it will be 1111, and A is 10. A 10 in the sense how much? It is of 1010. Then C, that is 12. If it is 12, 1100. E is 14. If it is 14, then 1110. 8 plus 4, 12. 12 plus 4, 2, 14. Then 1. What is the equivalent of 1 here? That is 0001. For this 2, it is equivalent to 0010. Okay. Then now I have to write all these together. Start with F, that is 1111, 1010, then 1100, then 1110. I have to put binary point, then 0001, then 0010, which is of base 2. Very, very important. Okay. If we have this hexadecimal point, while writing the equivalent binary numbers also, you have to mention this binary point. Okay. So this is how we are going to convert from this hexadecimal to binary. I hope you all understood my today's session. In my coming session, we'll going to work with this conversion from octal to hexadecimal, and then conversion from hexadecimal to octal number, and also we'll see about this computer codes. So after that, we are done with this number system concept. Let me meet you in the next session. Until that, keep learning, keep on growing. Thank you.